ChatGPT. Where's his office? Bancroft 1.27. Bancroft 1.27. Hey! 1.21. 1.22. 1.28. 1.23. Fire exit. The room doesn't exist.
AI chatbots are incredibly powerful, but have one massive flaw. They often invent answers that sound perfectly real, but are completely wrong. This is called hallucination. Large language models don't verify what they say. Hallucination isn't a bug. It's a consequence of how these models are evaluated. The industry tests them on benchmarks that only care if an answer is right or wrong. If the model says, "I don't know," it scores a 0. But if it guesses, it has a chance of getting it right, exactly like a student guessing on a multiple choice exam to maximize their score. The common fix is called RAG, Retrieval Augmented Generation. You give the AI a knowledge base, it retrieves documents and it answers based on those. It works for static information, but what if a student asks, "What lectures do I have today?" Or, "Give me walking directions to the Bancroft building." A static knowledge base can't answer those questions. You need something smarter. You need an agent. An AI agent doesn't just retrieve documents. It reasons. It looks at what you're asking and picks the right tool for the job, and adapts based on the results. To bring this to Queen Mary, I built a custom agent using Google's Agent Development Kit. But an agent is only as good as the tools it has access to. So I built 3. First, a RAG tool. I built a pipeline that scrapes over 20,000 QMUL pages and embeds them into a vector database. This ensures that AI grounds its answers in real, verifiable sources. Second, a timetable tool. It dynamically scrapes the student's live timetable, ensuring the agent knows what lectures the student has, when they have them, and where. And finally, a navigation tool. I mapped the campus into a custom geospatial graph. The tool doesn't just find the shortest path, it calculates every single turn on your route. Then, to give you real-world references, it calculates which side you'll pass points of interest on, and actively queries the RAG database to pull physical descriptions of those locations. So, instead of a robotic turn left in 50 meters, it gives you human directions like turn left and walk past the brand new ITL building on your right. When you give AI the right tools, it stops guessing and starts actually helping.
I need your help. Do you know where Professor Emma Melja Murazoda's office is?
What, who?
Professor Emma Melja Murazoda. I've got a coursework due for his office in 5 minutes. I need your help. So I went on the Queen Mary website, I asked it where his office is. Guess what? Well, it took a bunch of clicking. And then I went on AI, I asked that, guess what? It sent me to a room that does not exist in the first floor of the Bancroft, meaning I'm cooked. So, what can I do?
Well, the AI didn't know where the room was, so it just made it up. It hallucinated.
So you're telling me, because of some hallucinating robot, I'm about to fail this class?
Well, if you try the AI I created, it will help you out.
It says Alt 1.08. Where's that?
I don't know, ask it for directions.
It says I need to go 5 to 7 minutes. I've only got 4.
Go, run!
Hello, Professor.
Hello. You know the deadline was 2 o'clock.
I am aware, Professor.
It's 1:59, so you're lucky, just in time.
Here is my coursework, Professor.
Don't thank me. Thank what a miracle that you got here.
So, the chatbot just saved Kutai's semester. But that's just only 2 of the 3 tools. Let me show you the last one. Imagine it's a Tuesday, and you're not sure what lectures you have today. You can just go on the chatbot and type, "What lectures do I have today?" It replies, "Algorithmic graph theory from 4 p.m. to 6 p.m. in Bancroft 1.13. It's create the timetable in real time. Behind the scenes, the React frontend passes your message to a fast API backend over WebSockets. The agent takes over, queries the language model, uses local tools, and streams the response right back to you. But giving an LLM tools isn't enough to guarantee reliability, as language models are people pleasers by nature. So, I created a zero-trust system prompt. This forces premise verification. Ask about a professor's fake moon expedition. The AI doesn't just play along, it corrects the misinformation using retrieved data. The prompt emphasizes focus on exact numbers to verify ages and dates. To prevent identity mix-ups, it rejects ambiguous pronouns, ensuring the agent never misapplies a vague text chunk just because it says he, she, or they. When receiving a massive JSON of navigation data, the agent is instructed to think the route through and output high-quality, human-like directions. For transparency, every single fact comes with a clickable footnote, allowing you to easily review the source or jump straight to the website to read more. This creates a strict procedure for every response. Understand the query, gather data, verify the premise, and only then provide an answer. To prove that my QMEL support agent is truly reliable, I built an automated evaluation framework. First, an LLM generated a testing dataset from the scraped pages. These were categorized by knowledge scopes, from broad university facts to niche details, and 3 question types: simple fact retrieval, false premises, and hallucination bait. This dataset is fed into a simulated environment where a secondary LLM plays the role of a real user, challenging the chatbot with each query and asking follow-up questions. Next, the entire transcript is passed to a judge AI, which extracts each claim the agent made and cross-references it against the original knowledge base. The judge then grades the conversation, using metrics like correctness, hallucination, and refusal. Meanwhile, the timetable and navigation tools were evaluated manually, tracing each generated route on a map to guarantee correctness. Because an AI's knowledge base changes constantly, the system fingerprints the exact code and database state for every test. This ties every benchmark to a specific version, ensuring the results are scientifically reproducible and free from data contamination. To thoroughly test the system, I ran the evaluation loop across 270 VAG queries. Without tools, Gemma 3 27B hallucinated 50% of the time, and Gemini 3.1 Flashlight hallucinated 25% of the time. In the Agentic configuration, hallucinations collapsed below 3%. In separate tests for the timetable and navigation tools, the baseline Gemini 3.1 Flashlight model refused to answer timetable queries, correctly saying that it does not have access to timetable. However, for campus navigation, it confidently hallucinated fake routes almost 100% of the time. The Agentic configuration fixed both. To measure how much we can actually trust the system, I used the Omniscience Index. Rather than just tracking correct answers, this metric evaluates how the AI handles uncertainty. It relies on a simple rule. It is far better for the AI to safely abstain, rather than guess and take a massive penalty for hallucination. Using this metric, we see that standard LLMs struggle immensely with niche questions. However, my AI agent fixes this, delivering reliable performance no matter how obscure the question gets. When I map these scores against the parameter size of the LLM, we see a clear diverging line. The smaller lightweight models consistently struggled as they don't have the intelligence to correctly manage tools and interpret the results. Meanwhile, with the 12 and 27 billion parameter versions of Gemma 3 and Gemini 3.1 Flashlight, we see a massive leap in true reliability. And this holds true across the board. We see the exact same pattern whether the AI is answering RAG queries, checking live timetables, or navigating the campus. So, what did this project achieve? It proved that we can decouple an AI's accuracy from its pre-trained memory. Instead of relying on the model's probabilistic guesswork for things like walking paths or timetables, we can provide it with deterministic verified tools. The model simply becomes the intelligent, friendly interface for interacting with them. And through rigorous automated evaluation, I demonstrated that this approach fundamentally changes the reliability profile of the system. We took hallucination rates from catastrophic levels on tricky niche questions and reduced it to near zero. Most importantly, it proves that agentic AI is a practical, vital solution for building support chatbots that you can actually trust. Remember what happened at the beginning? The AI lied. With an agentic architecture, we give it the tools to finally tell the truth.